Hello AP students, this is Mrs. Politsky, and I have notes for Chapter 6. We're going to get into talking about learning, and as we go along you're going to need your packet to fill in some of our information. So here we go. What is learning? Well, learning is a lasting change in behavior or mental processes that results from experiences. This doesn't have to be something that's necessarily in a classroom. It can be anything that happens that, for the most part, changes your behavior or the way that you think. There are some different types of learning, behavioral learning and cognitive learning. The problem of observing mental events underlines a long-running controversy between the behavioralist and the cognitive psychologist. Behavioralists have maintained that psychology could be a true science if only it disregarded all the mental processes and focused exclusively on objective, observable stimuli and responses. The cognitive psychologists have contended that the behavioral view is far too limiting and that understanding and learning requires that we make inferences about the hidden mental processes. So, to talk about learning, you got to talk about the differences between that and instincts. Nearly every human activity involves some type of learning, and without learning we would have no human language, we would have no memory for our past or goals for our future. Instinctive behavior is heavily influenced by our genetic programming. Instincts are at work in a bird when they migrate, animal courtship rituals, and a few human behaviors patterned in, such as nursing newborns. Humans, for the most part, are influenced by learning and less influenced by instincts. There are some different forms of learning, simple to complex. We're going to talk about the simple one here first, habituation. This is learning not to respond to a repeated presentation of a stimulus. It's kind of like, when your mom keeps calling your name and you don't respond. And she keeps calling and calling and, you zone her out. That's what habituation is. There's also the mere exposure effect. Humans have a preference for stimuli to which we have been previously exposed to, aka the mere exposure effect. It's complex. One, it involves learning a connection between two stimuli. So a school child might associate 12 o'clock with a lunch bell. The second occurs when we associate our actions with rewarding or punishing consequences, such as being praised or reprimanded from a boss. Behavioral learning is a little more complex. It's a form of learning such as classical conditioning and operant conditioning, which we're going to talk about here shortly. That can be described in terms of stimuli and response. Cognitive learning, also a complex form of learning. We'll consider how sudden flashes of insight and the imitative behavior requires theories to go beyond behavioral learning. So I want to talk a little bit about this, the mere exposure effect. We have our crows down here, and the farmer puts in a scarecrow, and at first the crows are scared of it, but over time, the crows become used to it, and they're not scared of the scarecrow. So, we're going to get into talking about classical conditioning. And I'll have to say, the man that we're going to talk about here in just a moment is not necessarily considered to be a psychologist. In some cases, he's not even the man who coined classical conditioning, but he's the guy who kind of stumbled upon it by accident. And so we're going to talk about Ivan Pavlov. He was a Russian. Okay, he actually was a physiologist, and he was doing research for the most part on the salivation and digestive processes of dogs. Since salivation is the first step to digestion, this whole project went awry, sending Pavlov and his crew into a detour of the psychology of learning. So the problem begins with this. The animal begins to salivate before he was given food, and when the animal saw, or for the most part heard, the lab assistant bringing the food, they would start salivating. He stumbled upon an objective model of learning, one that for the most part could be manipulated in a lab to tease out the learned connections among the stimulus and the response. This discovery now is known as classical conditioning. And classical conditioning is a form of learning in which a stimulus that produces an innate reflex becomes associated with a previously neutral stimulus, which then requires the power to elicit the same response. Okay, that sounds all so complicated, but we're going to break it down a little bit. Okay, Pavlov's work on learning focused on the automatic responses known as reflexes. Okay, reflexes are normally triggered by stimuli that have a biological significance. Pavlov's great discovery was that these reflexive responses could be associated with new stimuli, hence a neutral stimuli, that had previously produced no response. First, they placed an untrained dog in a harness, which you saw on the previous slide, and set up a vial, or a tube to capture the animal's saliva. And then at intervals, a tone, primarily a tuning fork or some kind of bell, would be sounded, after which the dog would be given a bit of food. And gradually, over a number of trials, the dog began to salivate in response to the tone alone. Okay, kind of sneaky. But it's kind of like this. When you are getting ready for our class period, which is for some of you right before lunch, maybe the sound of the bell ringing might make your tummy start grumbling. It's kind of the same idea. A neutral stimulus, this is any stimulus that produces no conditioned response prior to the learning. When it's brought into a conditioned stimulus, or aka a CS, the assumption is that the same condition occurs after even one pairing of the conditioned stimulus and the unconditioned stimulus. When paired with a neutral reflex, producing stimulus, like food, will by itself begin to elicit a learned response to salivation from its original reflex. So I'm going to kind of pull this up a little bit and maybe pull this to the front so that way we can kind of see what's happening here. So we have an unconditioned stimulus. This is, for the most part, the food in the mouth. The unconditioned response is the salivating. So if a dog happens to see you carrying a plate of food, that is the unconditioned stimulus. And then eventually the unconditioned response would be for them to start salivating. We're going to pair the presentation of the food with the neutral stimulus. In this case, our tuning fork here. Sound the tuning fork, there's no salivation, no unconditioned response just yet. But as we present this over the time of conditioning, the neutral stimulus, when it's sounded and the food is presented, or unconditioned stimulus, we're going to have an unconditioned response, that salivation. Get rid of the food and just the neutral stimulus, which, by the way, neutral stimuluses always become conditioned stimuluses, in this case the tone. Eventually the sounding of that tone will elicit the conditioned response, the salivation. Sounds kind of complicated, but it's not as bad as you think. So, acquisition. The unconditioned stimulus, that's the stimulus that elicits an unconditioned response, the stimulus that automatically, without conditioning, provokes a reflective response. The food in Pavlov's experiment was the unconditioned stimulus because it produced salivation, that reflex. This response is called the unconditioned response, or the UCR, and the response that is elicited by an unconditioned stimulus prior to learning. So the unconditioned stimulus and the unconditioned response, this would be the UCS and the UCR, involves no learning. During acquisition, or the initial learning stage of classical conditioning. A neutral stimulus, in this case our tone, is paired with the unconditioned stimulus. Typically, after several trials, the neutral stimulus gradually will come to elicit essentially the same response as the unconditioned stimulus. Hence, we have acquisition, the initial learning stage in classical conditioning during which the conditioned reflex or response becomes to be elicited by the conditioned stimulus. The conditioned stimulus, the CS, in classical conditioning was previously a neutral stimulus, as we mentioned before, and that comes to elicit the conditioned response. Customarily, in a conditioning experiment, the neutral stimulus is called a conditioned stimulus when it is first paired with an unconditioned stimulus, or the UCS. The conditioned response in classical conditioning is a response elicited previously by a neutral stimulus that has come to be associated with the unconditioned stimulus. So timing is critical. The conditioned stimulus and the unconditioned stimulus must be presented close together as the organism can make some kind of appropriate connection. The range of time between intervals between the conditioned stimulus and the unconditioned stimulus will produce the best conditioning that depends on the response being conditioned. With me so far? So, what happens as we do this over a period of time? We're going to talk a little bit about something known as extinction and spontaneous recovery. So, in classical conditioning, and just so you know, there is also extinction when we talk about operant conditioning, slightly different. So, when you see the term extinction, remember it may have a couple different meanings here. But in the case of classical conditioning, extinction is the weakening of a conditioned response in the absence of the conditioned stimulus. Okay? So the spontaneous recovery is the reappearance of an extinguished conditioned response after a time delay. So an example would be we have our tone, that could be the tuning fork, or in this case a bell, and as we ring it, initially the dog may salivate. But over a period of time, if I'm not presenting the food with the bell, we're not pairing those things together, I could ring this bell and eventually the dog may stop salivating altogether. Hence, the conditioned response has become extinct because there is no unconditioned stimulus. Okay, let's say we forget about that for a while. Okay, maybe a week or two passes, and for some reason, I get the bell out and I ring it, and the dog might start salivating again. That would be our spontaneous recovery. So, conditioned salivation responses in Pavlov's dogs were easily eliminated by withholding the UCS or the food over several trials in which the CS, the tone, was presented alone. Extinction would occur, and this occurs when the conditioned stimulus is eliminated by repeated presentations of the conditioned stimulus without the unconditioned stimulus. When spontaneous recovery occurs, the conditioned response nearly always reappears at a lower intensity. The occurrence of spontaneous recovery is of considerable importance in behavior modification therapies for fear. But spontaneous recovery has a theoretical importance too. It tells us that extinction does not involve a complete elimination of the response from the organism's behavioral repertoire, or extinction suppresses the conditioned response. Generalization. Stimulus generalization is an extension of learned response to a stimuli that are similar to a conditioned stimulus. Pavlov demonstrated this by showing that a well-trained dog would salivate in response to a bell that made a significantly different sound from the one that he had been using during conditioning. So rather than a tuning fork, he might get a hand bell, or maybe he might get perhaps if this was modern day, he might get a modern day buzzer. And for some reason, the dog would salivate Okay, that would be stimulus generalization. Discrimination learning or stimulus discrimination. This is a change in response to one stimulus, but not to stimuli that are similar. Okay, so opposite of stimulation generalization. Pavlov and his students demonstrated this experimentally when they taught dogs to distinguish between two different frequencies of the tone or the two different frequencies of the bell. Conditioning and experimental neurosis. Pavlov also tried to demonstrate this. One stimulus was always paired with food, and the other was always paired with a painful electrical shock. Pavlov gradually changed the ellipse to become a little bit more circular, and as a result, the discrimination became increasingly difficult for the dog, and the dog's response grew more erratic. This would be experimental neurosis, a pattern of erratic behavior resulting from demanding discrimination task, typically one that involves aversive stimuli. Thank you so much.